Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 327. Time to cross a bridge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. I don't think this is a hard problem, and I'm not trying to say that to dismiss anybody. This is about, let me refresh this real quick. So we're about uh, like I'm recording this about an hour and 10 minutes into the 70 minutes into the contest, and we only have 127 total accepted, though I don't think this includes China. But that said, the number one thing is obviously there's just a lot of reading. This took me a while to read through what they want, and also, to be honest, when I did finally read through it, I was a little bit trying to look for what kind of weirdness I'm looking for, because I think this is just a simulation problem. And simulation problem is just means that basically they tell you the rules of some stuff and you have to simulate it in a way such that basically such that it happens, right? There's no, it's not, there's nothing algorithmic about it in theory. I mean, sometimes there are data structure things that you have to do to make sure the simulation or whatever can happen in a fast enough way, and will need to do that later on, or for this problem, and we'll show you. You know, we'll talk about it later on. But yeah, and it's just very code, very much a mess. I'll show you my code really briefly. It's about 82 lines of code, and so much and it's kind of not just like it's 82 lines of code, but it's 82 lines of very easy to make mistake type of code, and that's probably why this problem was taking a while. And yeah, I mean, it's not hard conceptually. There's a little bit of data structure, but yeah, and in fact, and I'm going to complain about this a little bit, is that I have a typo, which I'll point out later, that cost me about 10 minutes, and it would have changed my rankings by a lot if I had that 10 minutes back. So yeah, so it's very easy to make mistakes is my point here, especially since there's a lot of reading and then a lot of rules and so forth. So I'm gonna go over the. I mean, I kind of want to go over the rules, but I don't even know that the rules are that interesting. But because I think if you got to Q4 on this contest, which presumably means you. I mean, obviously, if you're watching this in the future, it might not be true for you. But if you did it during the contest, Q2 was also a heap problem. So in that way, it was also a little bit weird to me that there was two heap problems, because there's really also no complexity in this problem other than using the heap. So it's not like, oh, this heap and then this new thing, right? So that part I thought it was a little bit awkward, but these things, it happens. Yeah. But basically, it is just simulation. So you have to, and now that I use the data structure heap, it's just about keeping track of everything in an event situation. Yeah, in a what I call simulation, sometimes it's bookkeeping as well, because you have to basically keep track of where every worker is at every given time. And then you have one bridge, so you also have to make sure that bridge isn't being used. Let me know in the comments if they need more explanations, because I think honestly the problem description I didn't really have that many issues with. I mean, there's some stuff that is a little bit confusing, but you can reread it and understand it. I think I could be wrong, so definitely if you have comments about that, let me know in the comments. But some stuff in my classes, but yeah, but I think. Yeah, in terms of simulation, it's just just going through it. So I'm not gonna go over the things now, but I'm gonna go over my code and if I think maybe it's more interesting if you watch me solve it live, skipping the typo part. Maybe if you want to care about debugging, but to kind of see how I progressed it step by step, maybe that's more interesting. But for now, I'm gonna just go over my code. Basically, like I said, I have 4 heaps and a bridge, and each of these I'll kind of go explain it. This means that a heap for maintaining workers, putting new boxes, put new boxes, I guess, putting boxes in new warehouse, right? And the way that I use it is that basically, if a worker just got off the bridge, they have to they go on this heap, so then in the future when they're done we could take it out the heap, right? So this bridge heap is a heap for maintaining workers idling on the left ready to go on the bridge, right? And then this one is a heap for maintaining workers picking up boxes from old warehouse. And this one is, you know, for maintaining workers idling, or not idling, but working on picking up boxes from the old warehouse, right? No, wait, no, sorry. This is, even I confuse myself. A heap for maintaining workers with boxes picked up, ready to go on the bridge, right? Is it not idling? And then bridge is just it's just one variable because there could be only one thing on the bridge at any given time. So that's basically my idea. I also had another typo with boxes, but that's besides the point. But yeah, I maintain two things. One is boxes left. I also rename, I think n to boxes because it makes more sense. I should have renamed k to workers, but actually I don't think I used k at all, so that's why I didn't rename it. But yeah, so boxes left is, you know, boxes that are left in the work in the that's how many boxes that are left to pick up, and then these are boxes that are delivered. And of course we end when boxes delivered is less than boxes. I have some enums here, but basically if you look at, so these two are basically saying, okay, the current time is t, right? These two are saying, okay, are the idle people ready to like, did the worker finish delivering the box? And if they did, then they could get on the bridge, right? Or they could get on the queue to get on the bridge. And this is the same on the right side. If they finish picking up their boxes, then they could get on the queue to go back to go on the bridge to go on the left. And then here, so these two, the order doesn't really matter per se because it's just putting things, they act independently. This part, the rest of this, the order does matter because this basically is me implementing this rule set in the order that they denoted. And so the way that I keep track of this is, okay, if there are people waiting on the right bridge, this is basically if workers are waiting on the right bridge and the bridge is free, then we take the least efficient one. And here I'm not going to go with that much. I set it up by putting I missed this part though. I set up everyone by putting everyone on the left bridge, on the queue for the left bridge, sorted by or heaped by the efficiency. It's negative to get max efficiency, and then the tiebreaker was negative index. So, or the tiebreaker is the index, but the max index. So that's why I have a negative index. Very easy things to typo on, just to be clear. So I went very slowly on this one. But yeah, going back to here, if the bridge is free, then we just put it under the bridge. So bridge now becomes a tuple of things, including the direction. And actually, not gonna lie, I put the direction in the wrong index, and this is where if I had an actual name tuple or something like that, then maybe I could have caught it. But you know, such is life sometimes. You know, I swapped two things, and then it cost me 10 minutes to kind of just look through everything to debug it, and I couldn't understand why for a while. But yeah, and I put a continue here because that means so that on the same time period, I can do other things, and not necessarily in this order and stuff like that. I don't know that part is necessary, but it ensures that the time happens in a consistent way. And the way that this problem worked out is that after you set something on a bridge, obviously this cannot run anyway because bridge is none. But in theory, I guess only if this is 0 that this can happen. But it works more in a general way, so that's why I did it that way. And then basically, if the bridge is free, if the bridge is not free. So these two things are mutually exclusive anyway. But if the bridge is not free, but I just implement it in the direction that, or in the order that the instructions gave us. So if the bridge is not free, then we check to see if they get off the we see if they get off the bridge, right? Because if it's not time yet to get off the bridge, then they just don't get off the bridge, right? And this is basically, we take the variables out of the bridge, we set the bridge is equal to 3. If it's going from right to left, we put it on the left heap. We set the time to equal to the time plus the time it takes to put the box in. So this is just to put down the boxes. So in t plus pn, it'll be ready to, the worker will be ready to be free again. So that in t plus pn, this will be, happening, right? The same thing here, except for the right box. So we pick it up because it just got off the bridge on the right side. It goes to pick up the boxes. And of course that it is ready to pick up the boxes in t plus po. And then lastly, this is basically the same idea. So I'm not going to go into detail that much, but but basically now on the left side, on the right side, no, this is on the left side. If there's still boxes to be picked up on the right side, and the bridge is free, then we go on the bridge. That's basically what this is saying. And then we set the bridge if the bridge is free. And of course, because this thing happens first when the bridge is free, and because we have continue here, this enforces the priority that right goes left before left goes right. And that's pretty much it. And then if none of these things happen, then we increment t because time moved forward. And if you watch me solve it live, I was actually debating submitting this at this point, but I put in a really big case. Maybe I could emulate that case again, but it's just even like, you have 2 workers and you have 10, the other way, I think. You have 10,000 boxes, you have 2 workers, and then you have 1,000. It takes a long time, say, is the short answer. And I think the max answer is 20 million. But yeah, so then that means that if you return 20 million, that means t increment 20 million times, and that means all these if statements, all these while statements happens 20 million times. So here it actually runs really fast. But if we didn't have this, for example, which I didn't have initially, I think the first time I ran it during the contest, it took 9 seconds. So I was like, well, this is an obvious thing that I need to optimize. It might even time out now, but yeah, 8.6 seconds, which is just as bad. The idea here is that we're saying, okay, the next event that's happening, it's going to be one of these 3 things, right? It's either the bridge, someone gets off the bridge, or a worker is free and maybe possibly can get on the bridge, or someone can get off the right side or finish picking up the box and can get on the bridge on the right side, right? And basically from these 3 things, we take the thing that is the next event. This is basically a min of these 3 things, but I wrote it out this way so they're slightly more performant because Leetcode things, right? And then basically I'm saying if the next event is in the future of t, we just accelerate it to p, so that now in the next loop it will trigger one of these 3 events, or maybe more if they happen at the same time, but at least one event. So then this ensures that at every loop that it gets to here, it in the next loop at least one event happens. And because of this, because there's only 10,000 boxes and each boxes will happen like, there'll be 5 or 6 events. I think there's only 5 events because there's only 4 heaps and a bridge, but maybe 5 or 6 events each. Then it'll only take 10,000 times 6 times instead. So that's basically the upper bound in terms of the number of time each step takes. And of course, each step takes, log of h, where log of k, I guess, where they're only 10 to the 4th, which, it's like 10 heap operations or whatever. So maybe it's fine. And that's only if all the other conditions held. So yeah. That's a lot of talking. But yeah, so yeah, like I said, the complexity, this loop will only happen the number of state changes time at most, and the number of state changes time for each box will be at most 5 or 6 times. Let's just say 10 times because the I don't know number of I don't know that because yeah, looking at here, it seems like each box only has like 4 or 5 states. So let's say 5 states. It's a pessimistic. So then then this is going to be O of 5 times boxes, which is K for some reason, and then times and each of one of those events will have a log of n result, which we take away the 5. So then this is K log n for time, and then for space, this is O of n because all the heap does is keep track of each of them have at most n items, and we have like 4 or 5 heaps. We have 4 heaps. We could have probably optimized this a little bit because one thing that I realized later on, and actually, if I had now that I think about it, if I had done it that way, I would not have been able to make my typo. Is that if we only need to keep track of index and direction, and then we could have gotten this from the original input. It is what it is. Right. So yeah. Yeah, that's all I have for this one. Let me show you the top of the code, the middle of the code of the while loop, and then maybe the end of the code here if you want to curious. Let me also make it smaller so that you can see. Oh man, still cannot see everything. But yeah, here's the top again, and then here's the bottom again if you want to pause and read it. It's not the best code, not gonna lie, right? But this is also a code where, or this is a problem where it's just simulation and maybe that's just what it is. Cool. That's all I have for this one. Let me know what you think. The video is long, but a lot of it's debugging and a lot of it's just typing. I don't know if it's worth watching the live solve, but if you're curious, you're definitely, the live solve that I had during the contest is happening now. Okay. And boxes from, okay. And K. K people and boxes, okay. This is so much reading. Left to right, okay. What is going on? Which is the bridge? Bridge is free. On the right side gets to cross the bridge. Lowest efficiency. Okay, the bridge is free and then okay. I can't tell. Is it just simulation, or I don't get why. Okay, and 10 to the 4th. Okay, don't know what that means. This. I see, because they could cross the bridge at the same time. Well, you shouldn't. The lowest efficiency first. Here's simulation, just a little bit of a mess, right? I don't get what the. This is bad habit, actually. Okay, so n, what is n again? N is the number of boxes from the right side. Who moves stuff from right to left on this? What is K again? K is 10 to the 4th people. and the n boxes. So what is the upper bound simulation? If each one takes 1,000, don't know actually. With 0 goes from left to right. Why does it only take 1? Oh, I've been misreading this. Okay, fine. Okay, so there's a left heap. There's a right heap. And basically, this is so annoying. Old is on the right. People start on the left. Okay, so for out, pick old, right to left, pick new. In time, we want to sort, and let's enumerate this. Okay, yeah. Okay, so we always want the lowest efficiency. And if they're equal, then we pick the one that's later, which is, what a mess. So basically we want them. Okay, fine. Efficiency is just plus right? So they say, so then now left heap, because we start on the left. We have this efficiency, we have the index. We want to maximize this, both of these for some reason. So we have to do this thing. Okay, let me heap all these. I think that's okay. The last worker reaches the left bank. Do they all have to go back to the left? I guess so. Okay, this is kind of confusing as hell. Has anyone solved this yet? That's what I'm curious about. Not really, but what's K again? K is the number of workers. Okay, I knew that. Okay, so then now we simulate. So the bridge usage. How do I simulate this? Bridge is equal to. I don't know if this is right. Or like I don't know what I want to do. Okay, so if bridge is free, then okay, so then now we want to follow these rules. I think the rest looks out a bit. Just put it here for now. Okay, so okay. So let's just do a while true. I don't know if this is good, but right heap is if length of right heap is greater than 0, then let's cross the bridge. I have to do something about it, about the bridge. Just a lot of heaps, really. Okay. So now what we get is the index and index is equal to negative index. We don't care about the efficiency. I guess we could do it. We could care about it a little bit because we need to put it back at some point, maybe. I don't know if it's here. And then now it goes to the right? So then bridge is now then just, I don't know, just this worker. Say, I don't know if this is a good way of doing it. And then the time, it's going to be, let's say tier 0. So the time that expired would be t plus going from right to left. Okay, maybe. Right. Okay. And then here we continue, maybe, just to reset it a little bit. Otherwise, the bridge is not going to be none. Then if the okay. Wait, loss efficiency is the one with the higher number, right? Okay. The way that they say is so silly. Okay. If okay, if otherwise, if bridge is not none, then someone's on it, and then if t is greater than or equal to bridge of 0, then bridge is equal to none, maybe. And also this can just be a tuple, it doesn't have to be a list. And then yeah, equal to bridge, and then bridge is equal to none, and then now it gets to the left side, right? Oh no, it has to put down. Yeah, okay. So left. This is so silly. I think it's just like a lot of heaps the entire way. Because they're now left box heap. No, this is left bridge heap because they're all good. And then now if on the how people doing? Did anyone finish it yet? Nope. Okay. I'm just curious. But then now we can put it in the left box, right? So it's not available until so it'll be the current time plus put down. What's pn again? I don't know these variables. Put new. I'll put into the new. Okay, fine. Index. So this will be based on the time. Okay. And then we continue, say. Otherwise, nothing happens. And then now, and this is still dealing with the bridge for now. Okay, so the bridge is free, and there's at least one box left on the right side. If n is, let's call it boxes. Wow, this is so confusing. If boxes is 0, and length of left bridge heap is greater than 0, and bridge is none, then we do the same thing here and put it on the bridge. But now we're going from left to right. Except for this is a left bridge heap. And left the bridge heaps we care about it. Okay. And then okay. I think that's it for the bridge maintenance. Otherwise, we have to pick up and drop stuff. Right? So basically, while length of left, I feel like okay. Oh, I don't, this isn't quite right. And also I don't even push the heap, that's why this is not right. And the bridge can only be used from one direction. So okay, so we actually want to set this to left to no, right to left. Okay, so then now, yeah, okay, and then direction is equal to this, and then if direction is equal to right to left, then this is the left box heap. Forgot to do it because I was else, same thing but right box heap. Probably could use a variable for this, but whatever. Yeah, fine, let's do it. If I have a typo, I might need to change it. It will be a little bit better. Okay, so while otherwise, well, I think we just need to do this anyway, so okay. Let's do in the front then. It's greater than 0. And the first objects is greater than, is it greater than or equal to? I have to, I really have to check all this though. Still no one. While this is true, that this better not time out because that would be really sad. Oh, I have to do direction here, and this is left to right. Okay. Right, because it's a left bridge heap. Okay, and then now, if the left box is done, then we pop it. What do we put in the left box heap? This thing. So it's time. Index. I guess index could have been okay, but because we don't really need to sort by all these other things. Mistakes we made. Might refactor it later. Okay, so then now we pop it and then we put it into the left bridge heap. Yeah, okay. And then here we have to do this efficiency thing. So I have to bring it back. Bridge heap. Yeah, okay. The bridge heaps should have this. Okay. And then the right side. I think we're mostly done, except for we have to accelerate it. Because right now, it runs one at a time, which may be too slow. Line is that 39? Is that not what? Oh, there's a time component that I guess I just ignored. Right box heap of 0, 0. Oh, we don't break because I am an idiot, but that's fine. Oh, and in this case, no. If this is done, okay. So then now this is left delivered. Okay, fine. So boxes left is equal to boxes, and then now boxes left is delivered is equal to 0, right? And now we say in here that we deliver the box, and then here boxes. Well, actually, on attempting to pick up, you should already remove the boxes. So if that means that in this case, going from left to right, adding it to the box heap would already be okay. So while oh yeah, and then we don't return. So yeah, so then return T maybe. We'll see if this is even close. 1 and 20. I don't think that's right. Why is that 1? But this is a mess, and no one has gotten it yet, which is actually, I don't know, surprising. It's a mess of implementation. It's not a hard problem, but zero, 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 left to right. Okay, let's see. This is going to be a mess. Let's see. Is it right? Well, that's not the right place, is it? Should be here first. Okay, so it's 0, 4, and index 2. Did I mess that up? Index 2 is right. T and then, oh, this is, I just copy and paste. Well, okay, fine. Okay. And then 1 to 2. Pick up a box from the old warehouse. So pickup is right box heap. So okay. Oops. So it's just the index person and T plus. Oh, I think I don't do this right. Oh no, it's here. Oh, this is wrong though. This is pickup for the maybe I'm just better just do it this way. Pick up and then, so going from right to left it's going to put new, put old. Okay, maybe that makes it a little bit better. I don't know. But anyway, but this is, it's just T. There's no thing about it in an index. The 2 boxes. So from 10. No, that's already a different case. Okay. So this puts it into the bridge. The bridge now going from left to right. Okay. So then left to right, it goes here, go put in the right box heap, right? And then T pickup and then -1, right? So okay. Pickup. Scheduling a pickup. Okay, pickup at 1 to 2. Okay, that's fine. And then we put it into the right box heap, right? Huh. Did I not reset this? No, I said reset bridges none. Wait, I think there's a thing with this is really sad. Pick up on the right. Oh, the answer did change, maybe, but it's still not right though. Pick up on the right. Okay. Why is this not right? Why is this not triggering? Oh, I think I did. It should be boxes left here, not 15 and 67. Still wrong, I believe. 15 is definitely way pessimistic, but at least I finally got it. Or I don't know. I fixed one bug at least. Making sure that I don't use any stupid voice. I think this one has to be here. And then now it's an infinite loop. Why would that be? Well, 13.1 is still wrong though. I don't know that I have the endurance for this. Okay, at least we can do this one. So pick up right, pick up right pickup box from at times 7. Is that right? Wait, what? Why doesn't another person? Maybe I misunderstood this. Oh, and also you have to return the last worker reaching it, not just dropping it off, which is kind of silly. After all boxes have been put in the... Oh no, okay, well... No, maybe not, I don't know, but it's still not right. Why am I doing 13? Because... Okay, so then it goes 1 to 2. Right pickup White box pickup at time 2. Okay. I mean, I don't print the other stuff, so that's maybe why. But actually, it looks pretty okay. Actually, I don't know if it's pretty okay, but I mean, I think I'm returning the wrong thing, but it is actually white box pickup. So times it picks up the white box at 7, which is actually maybe not right. What is n? N is just one box, right? So why am I picking up more boxes? Okay, so that's where I am wrong. So white box pickup, put in the right heap. Oh god, I just, yeah. Okay, so then this is good, but I don't get it. Okay, so time 2, 1 box left, got picked up, and then now, right? Oh, basically, it was adding people to the bridge from left to right, but I thought this only happens with boxes that's left is greater than 0. Left bridge heap, okay, yeah. Time 5. At time 6, what happens? Time 6. We deliver the thing, maybe? Okay, so at time 6, we get off the bridge, and then that's when we subtract. Come on, Larry, what are you doing? What is wrong here? At time 1, you pick up on the right, okay, and there's no more boxes. How did you get more boxes to put on the bridge? I mean, people has gotta start getting it now, but because I feel like if I'm not debugging, I would probably be closer. But why is it -1? What are you doing? Silly worker. Pick up right. Okay. So then now, where's the put down? We don't put down until here for some reason. Do I miss the no right to left bridge for right to left bridge to at 6? Did I put on the wrong heap? No, this is the right bridge. Right to left. I seem to have. No, this is the time. I am a dumbo. Wow. Okay, so this isn't quite right because we waited until the left one is delivered. Let's actually see if this other one is close. 59? Probably close. So we're probably close, but oh man, I can't believe I had that typo though. Okay. So then now we want the last person that left the bridge, right? So that's T. So basically, yeah, okay. Going from right to left, if length of, or maybe just like last T is equal to T, and then return it, Larry. Okay, so this is right, but then now I want to test a big case because I actually don't know if I need to accelerate this because I'm doing it kind of stupidly. Right, and then each of these could be 1,000, so let's make it 1,000. Doesn't matter, just make it the slowest. Oh, I guess n is whatever, and this is 2. All right, let's give it a YOLO submit. I mean, I don't know if this is the right answer, but I mean, is this worth 5 minutes of possible wrong answer? I don't know. Oh, what is going on? Why is changing this change everything? Dun dun dun. Okay, so that actually takes way too long. That takes 20 million, which is actually probably fast enough in other languages. But then now, okay. But I don't think this slows down. I mean, I can risk it. This is only 3 test cases and taking 9 seconds. So that means I have to do some acceleration. What is that? 9? I don't think this slows down the. All right, let's just do 10 first, and then we'll see if this slows down too much. It may be very close to time limiting, but I think we can set the t is equal to t plus 1, or just the next event, really. I mean, maybe just kind of get closer. I mean, the heap things would be a little bit more expensive, so that's probably why. 20 million is pretty slow, or a lot of operations. Okay, so then that means that so we want to get the next event, right? Basically, P is possibly next, and then we want to say this is infinity, say. And then if, instead of using min, that's what I'm doing. Oh, less than P. Okay. Oh, we don't care about the bridges. Only we care about the 2 box heaps, right? So, okay. This is why we don't YOLO, because I definitely would have not, yeah. That definitely would not have been fast enough. Okay, that's good. Let's give it a submit. Hopefully I don't make a silly mistake. Cool. Whew, that is a tough one. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, and everything in between. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye. Have a good rest of the week.